In this lesson, we're going to learn about using quadratic functions in applications or word problem solving. The goal will be to find either a maximum or a minimum value of some parameter. It might be a volume maximum or an area maximum. It might be the minimum cost. It might be the maximum profit. What this really gets at is finding a range or y value of a parabola's vertex, because that's where the extreme value is. Now remember, a quadratic is a squared relationship. So we're going to need the equation of a quadratic if it's not already given. And remember, that's got to be a squared relation in one variable. What we do to get the vertex? Well, we got four choices. We have finding the x-intercept, using the mean to get the axis of symmetry, and then the vertex being on the mean. We can complete the square. We've also learned a shortcut formula for finding the vertex. And lastly, I'm going to show you how to do this on a graphing calculator, if nothing else, at least for a check. So here's the problem we're going to work on. We have a farmer who's wanting to find the maximum total area here for 2 pens using 600 meters of fencing. Well, to start with, we're going to say the perimeter is 600 and it equals 2 lengths. There's a length here and a length here, and 3 widths, because there's a width, width, and width. All of this material needs to be fenced and needs to equal 600. Now, this is an equation that's in 2 variables. It's also a linear equation, not quadratic, since there's no degree 2. I can, however, solve for length. If I isolate this term, bringing 3w to the other side and dividing by 2, I would get 300 minus 1.5w, or 3 over 2w. The other relation I know is that area equals the overall length times the overall width. Now, if I substitute the length into this formula, which also currently has 2 variables, I can rewrite it and say area is now a function of width only, and it's equal to the length, which is described based on width, times the width. So I've just replaced the length with what the length is equivalent to. You'll notice at this point, this is now a quadratic, because I only have one variable, w, and it's multiplied by itself, therefore it's squared. Another thing to notice is that because the w term has a coefficient of negative 1.5 and a positive coefficient of 1, this is a negative quadratic, so it's a maximum problem because of the negative sign. The first method is the x-intercept method. The x-intercept is where y equals 0, or in this case, the area is 0. Now, it's already in a factored form. We can take advantage of something called the zero product rule, that when something times something else equals 0, one of these factors must be 0. That leads me to saying that this factor is 0, or the w itself is 0. Well, there's one x-intercept, or a w-intercept in this case. I should call it a w-intercept. This one leads to 1.5w equals 300. When I divide 300 by 1.5, it equals 200. There's my other intercept. What I'm going to do now is I'm going to sketch this just so I can get a visualization of what's going on. There's my input and my output. There's one 0, and there's the other 0. This leads me to knowing that the mean value is 100. The vertex is on that axis. It opens downward from there. That's the peak location. And I just need to find the area now, evaluated for an input of 100. Remember, I have an area function that depends on w. Well, a of 100 equals 300 times 1.5, substitute 100, times the w, substitute 100. This is 150. 300 minus 150 is 150. 150 times 100 is 15,000. And this is my maximum area, the y value of the vertex. That's one method. Here's the next method. Let me write down my area function, because I'm going to use this again. Now this time, actually I'm going to rewrite this. I'm going to expand this by using distributive property. And this is like y equals ax squared bx and c, my a value negative 1.5, b value 300, c value 0. To complete the square, I factor out the a number from both terms. That leads this to being negative. 300 divided by 1.5 is 200. And now I need a number that completes the square to make a perfect square trinomial here. Half of this number squared. 100 squared. I add it, I remove it. These three terms form my perfect square trinomial. It leads to a binomial square with a minus sign and half that value. Don't forget the negative 1.5. So what I'm doing is I'm writing standard form to get the vertex. This is going to be minus 1.5 times negative 100 squared. This multiplied by this. Now first I square the 100, then I change the sign. So this is actually a negative number times a negative number, which leads to a positive number, and that result is going to be 1.5 times 10,000 or 15,000. This part was already finished, the binomial. And so I've got my standard form, I've completed the square. What I do is interpret the answer. The vertex is 100 comma 15,000, and what that means is a width of 100 produces a maximum area of 15,000. The same answer I had before, done a different method. There is a third method. We learned a shortcut, the vertex formula. The vertex is negative b over 2a comma c minus b squared over 4a given the general form ax squared bx and c. Now in our case, remember, we had a of w equaled negative 1.5 w squared plus 300w. So a is negative 1.5, b is 300, c is 0. We substitute in negative 300 over 2 times a, comma, c minus b squared over 4a. All right, 2 times negative 1.5 is negative 3. So I have negative 300 over negative 3, which clearly is going to be 100. And 300 squared, well, that's 9 and 4 zeros with a minus sign over negative 6. A negative times a negative makes positive. 90,000 divided by 6, 15,000. You can use a calculator to check. Again, same vertex as above. This is my width, and this is my maximum area. A fourth method. Okay, we're going to take the equation as presented, and we're going to put it in a graphing calculator. So, I've written it down already. Now, we don't get the choice of w and a here. My input is x, my output is y. It's a function model. But this is what we were given. 300 minus 1.5w times w equals area. Now, we do need to know a little bit for the calculator here. We need to recognize that there's a 0 at 0 and a 0 at 200. So we're going to need to control the window. The minimum value of x is 0, and as I said, the maximum value is 200. I'd like to scale this since 200 is going to span a fairly small space. Let's go by 50 units. Now, my y value is my area, and I'm not sure what the area is, but there's a really neat tool on the calculator. Push the zoom 0 button, and it will fit a window to what we need. There's our parabola. So we need to know where this is. There's a tool to do this on the calculator. I go second function, calculate, and I choose maximum, option 4. I'm going to be asked three things. I'm trying to bound where the maximum is, to the left and the right. So it says left boundary. I want to put the cursor somewhere on the left side. It doesn't matter where. I can move the cursor with the cursor keys till it's somewhere to the left. Doesn't really matter where. And then push enter. I'm going to be asked for the right boundary, somewhere over here. Now, I could push the cursor a lot of times I can also enter values. Remember that this went from 0 to 200. Let's enter 150. 1 or 110 for that matter. Anything over to this side. That's my right boundary. Push enter. Now it asks for a guess value. Just move your cursor anywhere into that region and push enter. That is the result. A maximum value width of 100 gives the vertex of 15,000. Notice the calculator had a slight rounding error. We need to interpret those results and round that off. But that's how you use your calculator to solve this problem. I wish you success solving your own problems.